These are Planck lengths. They're given by h. It's a length. When a ship has some speed and it's crossing over space, it's a distance over time. It's crossing some amount of Planck lengths over a certain amount of time, h over t. This is energy. Planck lengths times the speed of light over the frequency. As the ship is flying through space across energy, the amount of Planck lengths is increasing. It's E equals mc squared. And E over c squared equals mass. So the mass is increasing as the speed increases on the front of the ship. As the speed increases, that mass is then applied to a gravity equation. Gravity equals the mass of the ship times the mass of the Planck lengths that it's crossing in time over the radius between them squared, which is actually going to be a very minimal number. It's going to be right at the ship's nose. So as the ship increases in speed, it falls forward. And that is the first law of motion. When it's relating its speed to the position of another object, when velocity is being related, velocity is v, and when it's being related the speed and position of one object related to the speed and position of another object. When this is the same object, like the ship, then the ship understands or observes that its speed is zero, except when it's accelerating. And when it's accelerating, it feels a g-force that's equal and opposite to it. It's 0 plus a to c. That would look like this. 0 plus a, the arrow from the 0 plus a to c plus g with an arrow that way. And that's measured by an accelerometer. This part changes the Einstein relativity equation from mc squared over the square root of 1 minus velocity squared over c squared, which normally gives an infinite mass, right, and prevents the ship from going any faster. But independently, this changes to 0 because that's measurable by an accelerometer. That this gravity force is only appearing when it accelerates independently, relative only to itself, right? And so it obeys the first law of motion. So mc squared over the square root of 1 minus 0 plus a squared over c squared. If there's no acceleration, then it has mass over 1. And so its momentum p is equal to the first law of motion. P equals inertia. Right? Because its momentum is carrying it at some speed automatically. And that speed is driving it over these Planck lengths over a certain amount of time. And that's increasing the frequency and the energy that it's encountering at the front of the ship.